We are recording. Thank you. And Sir Ralph is not here today. So Ben already has a job. Krista, can you be my reminder to record person? I saw that you unmuted, but I didn't hear you. Okay, great. Thank you. So we're just going to do these definitions so that we have a common starting point. So an angle in standard position is one in which the vertex or the turning point is at the origin, the initial side is along the positive x-axis, and the terminal side is where we go to measure the angle. So two angles are coterminal if they have the same initial side and terminal side. So for instance, this angle 120 degrees, which is the same as, who knows that angle in radians?
Uh, 2 pi over 3.
Perfect. That angle is coterminal with negative 240 degrees, which is negative 4 pi over 3 radians. So coterminal just means they have the same initial side and the same terminal side. It doesn't mean anything more. A reference angle is an angle that is acute, that is less than 90 degrees or less than pi over 2 and is positive. So let's just look at this example, 120 degrees or 2 pi over 3. What's the closest way to go from this terminal side to an x-axis? Would we go?
Move it down 60 degrees.
Perfect. So that means that the reference angle for 120 degrees or for 2 pi over 3 is going to be, let me put it in red because everywhere else it's in red. It's going to be this distance. And like Ben just said, it's going to be 60 degrees or pi over 3 radians. And notice something about the radians. The angle in either case, the angle was measured with what denominator?
3.
3, and the reference angle was pi over 3. That's always going to happen. So if you're in radians and the angle has a denominator of 4, then the reference angle will be pi over 4. If the angle has a denominator of 6, the reference angle will be pi over 6. That will always happen. Well, let's look at some images so that it's all the way clear. If the angle is in quadrant 1, then the angle and the reference angle are the same. If we're in quadrant 2, we'll take 180 degrees and subtract theta to get to theta prime, or we'll subtract theta from pi. If we're in quadrant 3, we're going to take the angle and subtract 180 degrees or subtract pi radians. If we're in quadrant 4, we'll subtract theta from 360 degrees or theta from 2 pi. But it's easiest to see that we're always going to the closest x-axis. In quadrant 1, the x-axis is 0 degrees. In quadrant 2, the x-axis is 180 degrees. In quadrant 3, the x-axis is 180 degrees. In quadrant 4, the x-axis is 360 degrees. And of course, this is 2 pi, 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 0. So we were using reference angle terminology before this, but now we've got reference angle defined. To find the reference angle, the steps are to find the coterminal angle between 0 and 2 pi, and then to find, because that will tell you what quadrant we're living in, and then to find the reference angle using this diagram above, and then you find the trig functions of theta using the reference angle theta prime, and then you correct for the SIGN, the sign for the original theta. So for instance, to find the reference angle first for negative 79 pi over 4, there are two things I need. I know that theta prime is pi over 4. So the only other thing I need is in which quadrant is the original theta. Now this denominator is 4. I don't want to add and add and add and add. That would take forever. And that's why I made the numbers big. But how can I start at negative or positive? It doesn't matter. How can I start at 79 pi over 4 and get quickly to something closer to 0?
You could subtract 8 pi over 4, or add 8 pi over 4.
Yes. So we could add 8 pi over 4. Could we add lots of them? What could I
Yes.
do to 8 pi over 4 so that when, in this case, we're adding, we get as close as possible to something between 0 pi over 4 and 8 pi over 4? In other words, what could we multiply 8 pi over 4 by so that we add a lot of them to this negative 79 over pi over 4?
So you would add 9 of them. So just multiply by 9.
Okay, and how did you get to 9?
Well, 8 times 9 is 72, but
Good.
8 times 10 would just be 80, and that's too big.
Okay, good. So you saw how many times 8 goes into 79. It's 9 plus something. Moment, por favor. Okay. So that's how um that's how Ben got to 9 times 8 pi over 4. So let's see. 9 times 8 pi over 4 is 72 pi over 4. And let's add that to 79 pi over 4. Let's see. So we have negative 79 pi over 4 plus 72 pi over 4. And negative 79 plus 72, what is that?
-7.
Good. Excellent. To get a value between 0 and 8 pi over 4, we just need to add one more time. Why are we adding 8 pi over 4 rather than 2 pi?
Because 8 pi over 4 has the same denominator.
Yes, exactly right. We know that 2 pi is the same as 2 pi over 1. We want the denominator to be 4. So we're going to multiply by 4 and we get 8 pi over 4. And 8 pi over 4 minus 7 pi over 4 is
Pi over 4.
good. The coterminal angle for negative 79 over 4 is pi over 4, the one that we want. We want a coterminal angle between 0 and 2 pi. So in which quadrant is theta if theta is negative 79 pi over 4? What did we just determine?
In quadrant 1.
Yes, good. So to find the trig function for theta, not only is the reference angle pi over 4, but theta's in quadrant 1, so we can think of theta as pi over 4. So the sine of theta is the same as the sine of pi over 4. And what is the sine of pi over 4? What are the two ways that I want you to think of the sine and the cosine of pi over 4? It's the only one that has two ways.
Oh, square root of 2 over 2, and then 1 over the square root of 2.
Good. The reason why we want both ways is that Alex will only accept square root of 2 over 2 for the sine and the cosine. But when we're taking the reciprocal of sine and cosine, the second form is much easier to use. Okay, so speaking of reciprocals, what is the reciprocal of sine?
Cosecant.
Good. So that means that the cosecant of pi over 4 is
2 over the square root of 2, or square root of
which,
2.
or square root of 2, yes. And that's exactly why I want you to remember the second form. Well, we know the same thing about, and this is the same as the cosecant of theta. We know that cosine of pi over 4 is also square root of 2 over 2, or 1 over square root of 2. And that means that which one is the reciprocal of cosine?
Secant.
Good. That means that the secant of theta is
Square root of 2.
good. Either way that you think of it, the tangent of pi over 4, anytime sine and cosine are the same, what is the tangent? Because one of the ways that we can think of tangent is sine divided by cosine. If the sine and the cosine are the same number, what is the tangent?
One.
Good. If the tangent is 1, what is the cotangent?
Should also be 1.
Good. Very good. So those are the 6 values for the cosine of it, for the angle being negative 79 pi over 4, because we were able to get that angle. We were able to see that it was indeed in quadrant 1, which means it was the same as all of the trig functions for pi over 4. I want y'all to go ahead. We'll do the second part separately, so I'm not going to have y'all do the second part of the try this, but I do want you to do the try this for theta being 55 pi over 6. I'm going to be here, but I'm going to go away like usual, and I want y'all to discuss this. Please talk. Word. All right. So now let's do the second part of example 1. We're not going to do this, the try this for the angle in degrees. And I really think it's harder to do questions where the angle is in degrees, because in radians, I know the reference angle is pi over 4, just because this is in lowest terms and the denominator's 4. But to find the reference angle, if theta is in degrees, what do I need to do?
You can start by trying to calculate the equivalent angle.
Okay, good. And how?
Subtracting 360 degrees multiple times
Perfect.
if possible.
So if we subtract once, what would we do if the beginning angle were negative?
Add.
Add. Okay, good. So if we subtract once, oh goody, we get to borrow. 13 minus 6. 13 minus 6.
7.
Good. 8 minus 3.
5.
Do I need to subtract 360 again?
Yes.
Good. 7 minus 6, 5 minus 3.
2.
Excellent. Where does 210 degrees live?
In the third quadrant.
Good. And I know that because for quadrant 1, this is X and Y. For quadrant 1, we go up to 90 degrees. Quadrant 2, we go over to 180 degrees. Quadrant 3, we go as far as 270 degrees. And then quadrant 4, we go as high as 360. So we're definitely between 180 and 270. What is the reference angle?
30 degrees.
Good. And how do you know?
Because if you subtract 30 degrees from 210, you get 180, which is the closest x
Okay, good.
axis.
And similarly, you could subtract 180 from 210, and you would also get 30. Excellent. And so now we just need the 6 trig functions of 210, which are the same except for the SIGNs, except for the signs, same as the 6 trig functions of 30. So it's not fair, but sine almost always comes first for cosine. The sine of 210,
Negative 1/2.
cosine.
Negative square root of 3/2.
These are the same values that we got before.
Yeah,
Okay, so everything is going to be the same. That's kind of boring. I'll make sure that doesn't happen in the future. And let's look at example 2. If we're given one value and the sign of another value, how do we go about finding the other trig functions? What I mean by that is, what if the tangent of the angle is negative 9/4, and we're told that the cosine of that angle is positive? How can I use that information? Tangent is negative, cosine is positive, to know where theta is.
because tangent corresponds with x. So if x is positive, we know it's going to be in the right-hand side of the circle. And if tangent, which is opposite over adjacent, basically sine over cosine, we know that one of them has to be negative. And since sine corresponds with y, we know that it's going to be positive negative, which would be the fourth quadrant.
Very good. So yes, in the first quadrant, we do have cosine positive in the first and fourth, but, and this is quadrant 1, this is quadrant 4, but only in quadrant 4 is the tangent negative and the cosine positive. So as long as the two values you're given are not reciprocals of one another, because would it help us if we were given the secant of theta and that the cosine of theta is positive? Would that tell us where theta is? Exactly. So we have to have two functions which are not reciprocals of one another. And we do in this case. So we know that the theta we're given is in quadrant 4. Here are the steps we're going to follow. If we're given an angle and we're given a quadrant. I'm going to draw a right triangle in the quadrant that I just said, and I'm going to write in theta prime, remembering that the actual angle is measured from the positive x-axis in the anti-clockwise direction, counterclockwise. Okay, so let's see. How can I label the sides of the triangle from what I know? Because I was given that the tangent of theta is negative 9/4.
Well, since tangent is opposite over adjacent, we can say that the opposite would be -9, and then the adjacent would be 4.
Very good. And how do we go about finding the hypotenuse if we're given the opposite and we're given the adjacent?
Well, since this isn't on the unit circle, it's not going to be 1, sadly. But we can square the opposite and adjacent, add them together, and then take the square root of that.
Perfect. So the square root of the hypotenuse is going to be the square root of 4 squared plus, pardon me, the square of 4 plus the square of -9 and the square root of that whole thing. Do I need a plus or minus for hypotenuse?
For a hypotenuse, no, because hypotenuses are always positive, but
Yes,
you
that's right.
should write it down just in case it's not a hypotenuse or whatever.
Good. Very, very good. Okay, so let's see. 4 squared,
16,
9 squared.
81.
Do I need to put a negative 81?
No, because a negative times a negative is a positive.
Perfect. And let's see, 81 and 16 are 97. And we already discussed that the hypotenuse is going to be the positive. So the hypotenuse is the square root of 97. Oh, that's beautiful. Let's write out in a prettier way our triangle. So we know for an angle, the acute angle in the triangle in the upper left, we know that the adjacent side is 4, the opposite side is -9, and the hypotenuse is square root of 97. And I tried purposefully to make this example not pretty. We're going to wait until the very end to rationalize anything that needs to be rationalized. So the sine of theta, where theta is measured this way, the sine of theta will be, remind me of the right triangle definition for sine.
Opposite over hypotenuse.
Beautiful. So the sine will be?
-9 over square root of 97.
Beautiful. And what goes with sine?
C cosecant.
Good. Good catch.
Thank
So
you.
we know that the cosecant is the reciprocal of sine, and the reciprocal of the sine will be?
Square root of 97 over -9.
Yeah, and I'm thinking of that negative being out front. It doesn't matter. It's the same, but it's easier to read. Okay, and now we've got the cosine of theta. In terms of the sides of a right triangle, cosine is?
Adjacent over hypotenuse.
And adjacent is?
4.
We know that secant is the reciprocal of cosine. So that means that the secant will be?
Square root of 97 over 4.
Beautiful. And finally, we have the tangent. We were given the tangent in the beginning as -9/4. So that means that the cotangent, which is the reciprocal of tangent, will just be?
-4 over 9.
Good. So this notation, 1 over something, it's the same as 1 over -9/4, but we just can flip any fraction to get its reciprocal. So finding the reciprocal of a fraction is easier almost than finding the reciprocal of a whole number. Okay, now we just need to rationalize the sine and the cosine. The reason why I want you to think of doing that in the last step is that the cosecant and the secant are much easier to find if we find the reciprocal of the unrationalized versions of sine and cosine. Okay, what can I multiply by to rationalize sine? And the same thing is going to work for cosine.
Square root of 97.
Beautiful. So in the numerator, we'll get?
9 square root of 9 square root of 97.
Good. And the denominator will be?
97.
Good. And the cosine, we have 4 over square root of 97. So we're going to multiply by the same thing. We'll have 4 times the square root of 97 over 97. And I'm gonna, let's see where we are. I would rather y'all do the try this number 3 than a try this that is like the one we just did, but I want to set up the one that we're skipping. So this is a try this number 2. If If the cotangent is positive and the cosine is positive, in which quadrant is theta?
Number one.
Yes, good. And we know that cotangent, let's see, in terms of a right triangle, what is cotangent?
Adjacent over opposite.
Good. So to set this up, we know that the cotangent is 1 over square root of 6. Let's label the sides of the right triangle. So the adjacent will be
1.
the opposite will be
Square root of 6.
and to find, let's just find the hypotenuse very quickly. We know that the hypotenuse squared is equal to 6 squared plus 1 squared. 6 squared is
Square root of 6 squared?
yes.
6.
And then 1 squared is just 1. So the hypotenuse squared is 7. That means that the hypotenuse will be
Square root of 7.
good. I'm going to leave it there, but I do want you to get practice finding reciprocals when the numbers are not nice. Okay, so let's look at the next example. And how's our time? Oh, I guess we're okay. Our next example is the tangent of theta is negative square root of w over 8. And they tell us that the sine of theta is negative. So let's just draw a quick coordinate axis and look at sines. Is tangent positive or negative in quadrant 1?
Positive.
Okay. And sine is
Also positive.
good. In quadrant 2, the tangent is
Negative.
and the sine.
Positive.
Tangent is positive in quadrant 3, whereas sine is
Negative.
good. And in quadrant 4, they're both negative. And which do we want? What combination do we want?
Negative. Negative.
Negative, negative. So that tells us that our theta, good grief, our theta is in quadrant 4. So it tells us where to draw our triangle. So always with questions like this, where the value given isn't something from the unit circle, isn't something nice. we're going to start by drawing a triangle and labeling the sides of that triangle. So we've got, I don't want you. I know that my theta is actually drawn from the positive x-axis around, but I want to think of a theta prime being right there. So in terms of that theta prime, we already said that tangent was whatever what, right triangle wise.
Tangent is the, oh yeah, opposite over adjacent.
Good. So opposite is going to be, which one is negative if we're in quadrant 4? Opposite or adjacent?
The opposite.
Opposite. So we've got negative square root of w, and the adjacent will be 8. Now we just need to find the hypotenuse. I know that the hypotenuse squared is going to be the opposite squared plus the adjacent squared. Let's see, opposite is negative square root of w. The adjacent is 8. What is negative square root of w squared?
W.
Good. And 8 squared.
64.
Beautiful. If the hypotenuse squared is this, we can take the square root of both sides, and we've got to throw in,
Plus or minus.
beautiful. But we know that hypotenuse is always
Positive.
good. So the hypotenuse will be the square root of w plus 64. For this question, we are not going to rationalize. Oh, there's Sir Ralph. We are not going to rationalize these answers because it's not too complex for us, but it would take extra time. And in this case, Alex will not require it. So if we have the 3 sides of a right triangle labeled, is it pretty easy to write out the sine, cosine, and tangent?
Yep.
Yeah. So let's see. We have the sine of theta and the cosine of theta. And we already were given that the tangent of theta is negative square root of w over 8. The sine is going to be
Negative square root of w over the square root of w plus 64.
beautiful. That means that what do we know if we know the sine?
That we know the cosecant.
Good. That means that the cosecant of theta is
Square root of w plus 64 over square root of w.
good. We know that the cosine is going to be
8 over the square root of w plus 64.
Beautiful. And that means that the secant of theta will be
Square root of W plus 64 over 8.
we were given that the tangent is negative square root of W over 8, which means that the cotangent will be
Negative 8 over the square root of W.
beautiful. Are these relationships kind of, do you see that we're doing the same thing over and over and over again? Right triangle definitions, you really need to know them. We're using the Pythagorean theorem over and over again, and we're using knowledge of the SIGNs, the signs in the four quadrants. So I want y'all to do, but I'm going to give you 5 minutes. I want y'all to do the try this 3. I'm going to go ahead and set a timer, and I'm right here, but I'm going to be gone.
Is the recording still in process?
Yeah, you're still recording.
My own, Sir Ralph, because you weren't here. In my comments, I'm going to change my comments to the try this that we just did. So we had the point well, we thought of it in 2 ways. We thought of we had the cosine was negative 3 over square root of 14. And that would make the other leg square root of 5. So we could have these values, but we just saw that it's also correct to have 1 negative 3 over square root of 14 negative square root of 5 over square root of 14, which is the same as negative square root of 5 over 14. And what I want you to learn is that the first one is correct, and the second one is what we call normalized.
By the way, the square root of 5 on the first triangle should be negative.
Oh,
Thank you very kindly. Thank you, Ben. Okay, so the normalization idea is to take something that is standard and make it more standard. So we know the right triangle definitions of all the trig functions. But we also know that when the hypotenuse is 1, those trig definitions are simpler. We can get to that by dividing every side by the hypotenuse. -3 divided by the hypotenuse, -5 divided by the hypotenuse, and square root of 14 divided by the hypotenuse. So square root of 14 divided by square root of 14 is 1. And in the notes, I do a short proof that that actually does work. I just want you to put that definition in your mind somewhere, because that idea of starting with something that's correct and moving towards something that is better and also still correct. That's something that we're going to revisit in about a month. But we're going to try to revisit the idea more often than that. Okay. I'm going to skip the next two examples and try thises because we really have covered all of that.
Quick reminder, we have about 20 minutes left in class.
Okay, thank you. I'm going to stop and start the recording.